Welcome to AI Tech Book. This is the Atlas, Episode 8, Evaluation and Observability. Two true failures from opposite blind spots. One team ships a code feature that demos beautifully. Weeks later, someone tweaks the prompt to fix one edge case, and quality quietly sags everywhere else. Nobody notices, because nothing was watching, no held-out test, no rubric, no pass-fail bar. They were flying with no simulator. The second team ships to real users. One morning, the error rate spikes. They have pages of logs, but no way to tell which tool, which model call, which subagent actually failed. They were flying with no instruments. You've spent 7 episodes building. This episode builds nothing new. It answers the 2 questions every one of those systems forces on you. Before you ship, how do you know it's good? After you ship, how do you know it's still good? The first is evaluation. The second, observability. They aren't 2 skills, they're 1 loop at 2 speeds. Evaluation is the flight simulator. Prove it flies before anyone boards. Observability is the cockpit. Every gauge live, plus the black box. Same checks. Cold on the ground and hot in the air. Most teams start an Eval by writing test cases. That's the wrong order. It's why so many Evals measure the wrong thing. The doctrine inverts it. Building a successful application starts with clearly defining your success criteria, then designing evaluations to measure against them. Criteria first, test second. Good criteria are specific, measurable, achievable, relevant. Watch the upgrade. Good performance is none of those. Accurate sentiment classification is better. But the one you can build an Eval against is this, an F1 score of at least 0.85 on a held out set of 10,000 diverse posts, a 5% lift over baseline. Specific, measurable, targeted, tied to a real goal. That sentence is the Eval. Even fuzzy goals are quantifiable. Safe outputs feels unmeasurable until you write it as under 0.1% of 10,000 outputs flagged for toxicity by your content filter. Now, safety has a pass-fail line, and real systems rarely ride on one number. Most need multi-dimensional criteria. F1 above 0.85 and 99.5% non-toxic, and 95% answered under 200 milliseconds. One word carried every example, held out. Measure on data you tuned against, and you're grading the test you already saw. If you're an architect, that discipline makes every later number trustworthy. Once you have a held out set, every answer needs a grade. There are exactly 3 ways to produce one, and Anthropic's docs rank them deliberately, fastest, and most reliable first, slowest, and most expensive last. The order is the lesson. Start at the top, because the top is cheapest and surest. Code-based grading is just code checking output. Exact match, does the answer equal the golden answer? String match, does it contain the key phrase? It's the fastest, most reliable method there is, and it scales to millions of cases for free. Its weakness is nuance. Code can tell you if a summary contains a word, not whether it's well written. When code can't capture the nuance, you reach down one rung to a model as the judge. LLM grading is fast, flexible, and scalable for complex judgment, but the docs warn plainly, test it for reliability first, then scale. The bottom rung, human grading, is the most flexible and highest quality of all, and the docs are blunt, slow, expensive. Avoid if you can. Between code and judgment sits a whole family, F1 for classification. Cozy and similarity for semantic consistency, Rouge L for whether a summary stayed on topic. The rule for the latter is 1 line. Choose the fastest, most reliable, most scalable method that still captures what you care about. Then 3 principles. Be task specific, automate whenever possible, and this surprises people. Prioritize volume over perfection. If you're a developer, that's permission to auto-grade 500 cases instead of hand grading 50. Here is the technique that scales human judgment to machine speed, and the one most teams get subtly, expensively wrong, using a model to grade another model's output. Done right, it's the backbone of modern Evals. Done carelessly, it hands you a number that feels rigorous and means nothing. 4 rules separate them. Rule 1, give the judge a detailed rubric, not a vibe. For instance, the answer should always mention Acme Inc. In the first sentence, if it doesn't, it's graded incorrect. A rule a model can apply identically 10,000 times. Rule 2, Make the output bounded and empirical. Force the judge to emit correct or incorrect, or a score from 1 to 5. Never a free-form paragraph. Qualitative evaluations are hard to assess at scale. Rule 3 is counterintuitive and it genuinely raises scores. Ask the judge to reason through its decision first, then discard the reasoning and keep only the verdict. The thinking makes the judgment better, you just don't keep it. Rule 4 quietly invalidates whole Eval suites. Use a different model to judge than the one that generated the output. Grade a model with itself, and you're measuring how much it agrees with itself, self-grading bias, and it inflates every score. And the cautionary tale, remember episode 7's research fleet? It's Eval used an excellent Llm Judge, scoring factual accuracy, citations, completeness, source quality, tool efficiency. It passed. And a human still caught what the rubric never saw. The agents preferred SEO content farms over authoritative sources. Rigorous and blind. If you're a technical PM, carry this. An Llm Judge is necessary, fast, scalable, and never sufficient alone. Everything so far you can run by hand in code. But there's a faster on-ramp. The Code console ships an evaluation tool that tests a prompt across many scenarios without writing a harness at all. For most teams, this is where Evals actually start. It lives in the prompt editor under the Evaluate tab. One requirement gates everything. Your prompt must include at least 1 or 2 dynamic variables in double brace syntax. That's what turns a single prompt into a test set. Each row of the grid fills those variables with different inputs. No variables, no test set. The gotcha that stops people on their first try. You fill the grid 3 ways. Add a row by hand. Ask Claude to generate test cases from a baseline set. Or import a CSV if you already have data. Then you grade. 3 result features do the work. Side-by-side comparison of 2 or more prompts. Quality grading on a 5-point scale. And prompt versioning. And here's the feature that turns a one-off test into a discipline. When you change the prompt, rerun the entire suite against the new version and see exactly how your change moved every case. Not it feels better, a row-by-row diff. These improved, these regressed. Want more depth? The Evals cookbook has code examples. But the console gets you a real Eval loop in an afternoon. The rerun button still relies on someone remembering to press it. Teams that don't ship silent regressions take the human out of that loop. They make the Eval automatic, and they make it block. This is Eval-driven development, the bridge between the 2 halves of this episode. Start from what you have. Scene 2 gave you a measurable criterion, F1 at least 0.85 on the held-out set. The console gave you a suite that reruns on change, plus versioning. Put them together and the criterion stops being a goal and becomes a bar. Every change reruns the suite, and if the score drops below the bar, the change does not merge. Be precise about what this is. Anthropic gives you the primitives, rerun the suite, version the prompt, define a threshold. The gate is what you build by wiring those primitives into your pipeline. It's a pattern, not a product you switch on. And here's where it connects to right now. The flagship model just moved, and a model upgrade is exactly a regression event. You don't adopt a new model on faith, you rerun your suite against it and watch the bar. Still passes. The upgrade is safe, drops. You caught a regression before your users did. If you're an architect, this is the habit that makes everything before it compound. That's the offline half. Prove it's good before you ship. Next, the live half, watch it run. If this helps you, subscribe. It's how these get made. Back to our second team. Staring at an error spike with no idea where it came from. That's the production question. And the doc stated exactly. When you run agents in production, you need visibility into what they did, which tools they called, how long each model request took, how many tokens were spent, where failures occurred. Logs alone don't answer that. Observability does. The agent SDK and Claude Code emit this data in a standard format, open telemetry, that any modern backend can ingest. That standard is why you're not locked in. The same data flows to Honeycomb, Datadog, Grafana, Langfuse, or your own collector with no rewrite. The data comes in 3 independent signals, and keeping them straight is the mental model for the whole half. Metrics are counts over time, tokens, cost, sessions, tool decisions. Log events are discrete records, one per prompt, per request, per error, per tool result. Traces are the shape of a single run, the spans that show what called what, in what order, for how long. Metrics tell you something's wrong. Logs and traces tell you what and where. Two caveats the docs insist on. First, all of this is off by default. Nothing is collected until you set the enable flag and choose an exporter. Second, the trace signal, the richest of the three, is explicitly in beta. Span names and attributes may change between releases. So build on traces today, but pin your dashboards loosely. Here is the picture that turns watch it in production from a slogan into something you can read. An entire agent run, every model call, every tool, every permission weight drawn as a single tree. Once you can read this tree, you can find any failure in seconds. Every span name is real, and the hierarchy is exact. The root is the interaction span. It wraps a single turn of the agent loop. The loop you learned in episode 1 is now one node you can click. Beneath it hang its children. Each call to the model is an LLM request span, carrying the model name, the latency, and the token counts. So you see precisely which call was slow and how much it cost. Each tool call is a tool span. Each hook that fired is a hook span. Look closer at a tool span because it splits in a way that's quietly brilliant. It has two children, blocked on user, time spent waiting for a human to approve, and execution, time the tool actually ran. If a run feels slow, that tells you instantly whether your agent was working or just waiting on someone to click approve. And now, the payoff that ties back to last episode. When the agent spawns a subagent through the task tool, the subagent's own request and tool spans nest under the parent's tool span. So the full delegation chain appears as one trace. Episode 7's fleet, made legible. The lead is the root. Each worker's run hangs inside the tool span that launched it. The tree doesn't even have to start at Claude through standard trace context propagation. The agent's whole interaction becomes a child of your application's span. Remember, this is beta. Span names may shift, but the shape is the shape. Traces show one run. Dashboards watch all of them. The metrics and event layer turns watch it into named numbers you can alert on, gauges that flare before a user files a ticket. The core metrics are named and countable, token usage, cost usage in dollars, session count, active time in seconds, lines of code, tool decisions. And token usage breaks down along the dimensions you care about: input versus output, user, team, model, even agent name. That last one matters after last episode. You can attribute spend to a specific subagent in your fleet. Two signals are worth alerting on. The first is the API error event with a crucial property. Claude Re tries failed requests internally and emits this event only once after it gives up. So one API error is one real failure, already past every retry. The second lives on the model request span, stop reason, end turn, tool use, max tokens, and critically refusal. A rising refusal rate is drift you can see on a graph before angry users. For latency, two numbers do the work. Duration in milliseconds, wall clock time including retries, what your user felt, and time to first token, how long until the response started streaming. One warning, the cost number from the result stream is a client-side estimate, not your bill. Perfect for dashboards and trends, but don't bill users or trigger financial decisions from it. For the real bill, use the usage and cost API to attach an end user identity, and those tool decisions and permission changes become a per user audit trail you can forward to a SIM, your security event platform. Every technique in this episode can be rigor or theater. Here are the 7 ways teams fool themselves into thinking they're measuring when they're not, and the one-line fix for each. If you remember one scene, make it this one. Trap 1, self-grading bias, grade a model with itself, and the score is inflated. Fix, a different model judges, and far to Thea, the rubric blind spot, the SEO content farm case, an automated judge passes what a human would reject. Fix, a human spot check. Trap 3, measuring untuned data, evaluate on what you optimized against, and it's a memory test. Fix, the held out set. Trap 4, vanity grading. A wall of prose feels thorough and tells you nothing chartable. Fix, bounded empirical output. Trap 5, the one with money attached, reading the cost estimate and reporting it as the company spend. It's an estimate, not the bill. Fix, dashboards from the estimate, financial decisions from the usage and cost API. Trap 6, lost telemetry on short tasks. If your process dies before the exporter flushes, the buffer is gone. Fix, shorten the export interval. Trap 7, the one with teeth leaking sensitive content. Content is off by default, but turn the flags on and you start shipping prompts to your collector. Fix, leave them off unless your pipeline is approved. Every fix is something you already learned. Screenshot this scene. One last practical question: where does all this telemetry actually go? The reassuring answer: you don't have to bet on a single vendor because Claude speaks a standard, not a proprietary format. The data leaves in OpenTelemetry's protocol, OTLP. Anthropic's docs name the backends that accept it directly: Honeycomb, Datadog, Grafana, and Langfuse, plus any self-hosted collector. The hub is the standard. The backends are plugins. Pick the one your team uses, or swap it later without touching your agent code. This is deliberate. The whole ecosystem is converging on OpenTelemetry, which is exactly why Anthropic emits it. So the durable skill isn't one vendor's dashboard. It's speaking OTLP-FO. Learn the signals, spans, and metrics in every compliant backend, today's and next year's. Just works. If you're an architect, build on the standard. Stay backend agnostic. 2 halves, 1 loop. What it means depends on which seat you're in. So here's the whole episode, 3 ways. If you're an architect, your job is the shape of the loop. Define success criteria before anything is built, specific, measurable, multidimensional, on a held out set. Decide where code grading ends and a model judge begins. And design for traces from day one. So the agent is a branch of your system's trace, not a black box beside it. If you're a developer, you live in the mechanics. Wire the console Eval or a code grader. Keep the judge a different model than the generator. Turn on telemetry, and when production breaks, read the span tree to the exact failing call, slow, waiting on approval, or a subagent 3 branches down. If you're a technical PM, you own the proof. Before ship, can we show it meets the bar on the held out set? After ship, which dashboard tells us it regressed? And does alerting catch a rising refusal rate before users do? And never report an estimated cost as the bill. 3 seats, 1 loop. The architect shapes it, the developer runs it, the PM proves it. 2 halves, 1 loop at 2 speeds. 5 ideas hold the whole thing up. 1, evaluation starts with a definition of good, written before any test, specific, measurable, multidimensional, on a held out set. 2, grade with the fastest, most reliable, most scalable method that captures the nuance, and climb to a model judge only when code can't. 3, an Llm judge needs a clear rubric, bounded output, reason then discard, and a different model than the generator, plus a human spot check. 4, in production, read an entire run as a span tree, your whole subagent fleet nested into one trace. 5, watch the signals that warn you early: the terminal API error, a rising refusal rate, latency split into work versus waiting. And remember, the cost number is an estimate, not your bill. The simulator and the cockpit, running the same checks at 2 speeds. That's evaluation and observability. The same loop at 2 speeds. Define good, gate it before you ship, and watch it live once real users arrive. Across 8 episodes, you've gone from a single agent to a system you can build, prove, and keep proving. Share this with one person who's shipping with Claude, and subscribe to AI Tech Book. The loop never really closes.